In Part 9 of Chapter 6, you will be reminded of a few tutorials that have links provided through Blackboard. You will also learn about two types of formal parameters and using reference variables as parameters. These tutorial videos are available in Blackboard. I provided them for anyone who needs additional explanations on functions. They cover functions, function prototypes, and function parameters, and the return function. I also added a few more tutorials to the list. So if you're having trouble understanding, it's just another method for you to have another explanation by someone else. So hopefully that will help you comprehend the complexities of functions. Remember our definition for formal parameters? Try to think of the meaning. Formal parameters are the values inside the parentheses in the function heading. There are two types of formal parameters that you can use. One is called value parameter. The value parameter receives a copy of the contents for the actual parameter. In other words, the actual parameter sends a copy of what those values are to the formal parameter. In this case, you can send or pass values to the function and get a value back. This works as long as the function is not a void function. A formal parameter that uses a memory location for the actual parameter is called a reference parameter. The reference parameter allows you to share a variable or a memory location from the main function to the subprogram or subfunction. By using the memory location, function main is aware of the value and will be aware if the value changes. If function main already knows about the value change, then a return variable's value is not needed. Function main already knows the new value. Here we have formal parameters. The value parameter, that is a formal parameter that receives a copy of the contents. So it receives a copy from the call, the function call, okay? Unless it's a void function, and that's a whole different story, okay? Reference parameter, you actually point to a memory address, and we'll get into more details in just a second. Remember again, a formal parameter is the value found inside the parentheses of the function heading. These values are received and used by the function definition. In order for the function to complete the task, the value of the actual parameter, or the function call, is copied to the formal parameter. This means if the values change because of your statements in your function definition, the actual parameter has no idea of the changes. Once the copy is made from the actual parameter to the formal parameter, there is no connection between the two. This can create problems if you need the updated values to be sent back to the calling function. So let's look at the slide. If a formal parameter is a value parameter, the value of the corresponding actual parameter, or the function call, is copied into it. This means a formal parameter has its own copy of the data. Once the copy is made, there is no connection between the formal parameter and the actual parameter, so it cannot pass a result back to the calling function. The formal parameter and the actual parameter have their own variables. This has limitations. During program execution, a formal parameter manipulates the data stored in its own memory space, so it has its own memory space. It doesn't share the same memory space. Let's look at a quick diagram. The value of the actual parameters m and n, right here, actual parameters, are copied to the formal parameter values. So they're copied over here, m and n. When the values of the actual parameters are copied over, this is called pass by value. So we're passing the value here over to here. Okay, so we're passing by value. The important takeaway is where and how the values are stored. Remember, variables are storage locations in main memory. In the function call in main, the value of m is 10 and the value of n is 20. This is over here in main, right? Function main. These values are copied over to here, right? So they're copied over to the formal parameters of the function heading. You are not passing the variable, but the value in the variable. The system sees the variables in the actual parameters in function main as one memory location. So C++ sees these as one memory location, and it sees these as a different memory location. Okay? There is nothing to link them together. So if you do some math and change those values, and then you want to bring the answers back to function main and do something else, you can't. They cannot be sent back to function main. It does not affect the actual parameter values. These are not affected. So if you were to print them, you would get 10 and 20 even if you called this function. How can we fix that? Well, lucky for us, there is a way around this issue. It is called pass by reference. So let's take a look. By using pass by reference, both the actual and the formal parameters look at the same memory location, not the variable name. In other words, you tell both to look in the same storage box. This means the formal parameters will see the changes in your values. The actual and the formal parameters both will see any changes. One other point, instead of copying or passing a value from the actual parameter to the formal parameter, you are passing a memory address. Basically, you're saying, hey, look in this location for your values. We are not passing values, we are passing addresses. You tell the system to pass the reference to a memory address by placing an ampersand between the data type and the variable. So here, this would be found in function main, and we assign our values, and here is our function call right here. And I have a function called add. Over here is my function. Here's void add integer, and here's the ampersand. So what I am saying is look at the memory location. So it will look at the memory location, and they're both. This is this memory's location, and this looks in the same place in memory to see that value. That way, if you do any math to it, the call is aware of the changes. It sees it. Okay? If a formal parameter is a reference parameter, it receives the memory address of the corresponding actual parameter. So now both functions will share access and know the value stored there. During program execution to manipulate data, changes to a formal parameter in the heading of your function will change the corresponding actual parameter used in your function call. When should you use a reference parameter? Reference parameters are useful in 3 situations: when the value of the actual parameter needs to change, when returning more than one value from a function, because remember, return can only have one value return at a time, so you might need more than one, and when passing the address would save memory space and time when dealing with large amounts of data. When you attach the ampersand, or that little and sign, after the data type in the formal parameter list of a function, the variable following that data type becomes a reference parameter, or it uses a memory location. This is the last slide for Part 9. Part 10 of Chapter 6 will discuss value and reference parameters and memory allocation, local versus global parameters, and the rules to access identifiers.